This is Math 2, Unit 10, Worksheet 3. We did number 1 yesterday for notes, so you guys are supposed to do this on your own. A peach tree produces 270 peaches per tree when 25 trees are planted per acre. For each additional tree planted per acre, the number of peaches a tree produces decreases by 5 peaches. This function is represented by P of x equals negative 5, x minus 40 squared plus 8,000, where x represents the number of trees per acre and P of x represents the total number of peaches per acre. All right, so A through E is going to help us produce a sketch of this peach growing phenomenon. So first thing we should do is add labels and axes, including the variables description words. So we have x is the number of trees per acre. So trees per acre, right? Okay. And where x represents the number of trees per acre and P of x represents the total number of peaches. Okay, peaches per acre. Okay, so go ahead and do that. And let's see, what's next? Focus on the equation used to model the total number of peaches. What will the graph look like? Be as specific as possible. All right, so let's see what we got. We know this thing is going to open up or down? Down. Okay, open down. We know that because of the negative. Is this guy going to be normal, skinny, or wide? Narrow, normal, or wide? Narrow. What else can we say about it? Is it going to have a maximum or a minimum? Max, and anybody know what that's going to be? 8,000, right? Right there. And what is the vertex? How about the vertex? What's it going to be? Negative, or I'm sorry, not negative, positive 40 and 8,000? Is that right? Okay, so let's see here. What else do we know about this thing? Anything? It's a good start, right? All right, so let's start with the vertex at 40, 80. So let's go every 5 here. So this will be 10, 20, 30, 40, 50, 60, 70, 80, right? 90, and 100. And let's say that we'll go every 500 on here. So we'll go 500, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, and 8,000. Okay? So let's plot our vertex first. So at 40 trees, we know they're going to have a maximum of, I'm following that up correctly, 8,000 peaches. What does that mean? What does 48,000 mean? What does X stand for? 40. Number of trees per acre. And what does 8,000 stand for? The number of peaches per acre. So it means the kind of the sweet spot, if you're a peach farmer, is 40 trees per acre, right? Make sense? Okay. So what's our, if we were to plot this, I don't want to draw it on my paper yet, but if we were to plot this, it would be a parabola like this, correct? Now, if there are 0 trees per acre, how many peaches are we going to get? 0. So this is the 0 there. And since we know all parabolas are symmetrical, we know at 80 there's going to be zero peaches per acre, right? So if you try and plant 80 trees per acre, you're just going to end up not getting any fruit, right? It's just too many trees for it to even produce any fruit. All right. So let's check out let's check out, what if you had 20 trees per acre? Let's go ahead and plug that in and just see what happens. So that would be -5 times 20 minus 40 squared plus 8,000. Okay, we can do this on the calculator, but I know 20 minus 40 is -20. -20 squared is 400. 400 times -5 is -2,000. And -2,000 plus 8,000 is 6,000, correct? So 20 trees per acre, you're going to get 6,000 peaches. And since we know they're symmetrical, we also know at 60 trees per acre, you should get 6,000, right? Which would be right there. And while we're at it, why don't we just try 10 trees per acre? Well, that's -5 times 10 minus, not 30, 40, I'm thinking ahead, squared plus 8,000. Let's see. Well, 10 minus 40 is -30. -30 squared is 900, right? Is that right? 900. And 900 times 5 is 4,500. And -5 would be -4,500. -45 plus 8,000 is 3,500. So at 10 trees per acre, you're going to get 3,500 right there, which we know is going to be also right there, I guess, if I did that right. If I count out right, boom. Is that right? Nope, should be, what am I looking at, 10? So it should be 70. Right there. Yeah. Okay, so our parabola, let's sketch that. All right. I feel like mine looks pretty good. Does yours look like mine? Nope. Figure out why not. All right, C, scale each axis so that we did that. Why does it make sense that the graph is only in the first quadrant? Well, can you raise negative trees on a acre? No, you can't. Can you raise or can you harvest negative peaches? I don't think so. So that's why it's only in the first quadrant. What's our domain? 0 to 80, right? So we can write this in interval notation, 0 to 80. All right? 0 to 80. What's our range? 0 to 8,000. Ah, thank you. Okay, 0 to 80 is our domain. 0 and 80, and 0 up to 8,000 is our maximum. All right. Let's see here. How many peaches do you expect if 0 trees are planted? We would expect 0. Why does the function predict? What does the function predict when the number of trees per acre is 0? 0 peaches, right? Show the algebra to support your answer. So that would be -5 times 0 minus 40 squared plus 8,000. Well, 0 minus 40 is -40. -40 squared is 1,600. And 16 times -5 is -8,000. And -8,000 plus +8,000 is 0. Okay? All right, the same thing if you put 80 trees per acre, because 80 minus 40 is 40. 40 squared is 1,600. 16 times -5 is -8,000. So 0 trees per acre or 80 trees per acre will produce 0 peaches. How many peaches per acre can you expect if 30 trees are planted per acre? Well, that's the one we didn't find, did we? All right, so -5 times 30 minus 40 squared plus 8,000. So that's negative 5 times negative 10 squared plus 8,000, which is 100. 100 times 5, or 100 times negative 5 is negative 1,000, plus 8,000 is 7,000. So let's see how accurately we made our graph. At 30, we should be at 7,000, and mine's pretty good. And which means, oh man, I'm pretty darn good. I should be a math teacher. Oh, that's a good one. Okay, and the last question, or the last two, I and J. How many trees should be planted per acre to maximize the number of peaches? That is 40. Good job. 40. Your vertex, I've said many times, tells you a lot. The maximum amount of trees you want to plant to get the maximum amount of fruit is 40 trees for 8,000 peaches. What is the expected maximum number of peaches per acre? 8,000. 40 trees. All right, let's move on. Okay. Let's see. All right. A stomp rocket is shot vertically upward with an initial speed of 64 feet per second. In height measured in feet after t seconds is given by h of t equals negative 16 t minus 3 squared plus 44. So t is time in seconds, right? And what do we got? H is height in feet. Always label your axes. Okay, what do we got here? Well, let's just get down to it. What is our vertex in this graph? So what we've done so far to graph parabolas, and it's not what we'll always do, but a good way of doing it when it's in vertex form is identify your vertex, which is 3, 144. Excellent. Okay, so I don't know, let's count by twos and we'll go 1, 2, 3, 4, 5, and 6. That should be enough. And what are we going to count by here? We want to go, should we go by, I don't know, what should we go by? Tens? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 150. All right, should have moved my labels back a little bit. But let's go ahead and graph our vertex. Our vertex is at 3, 144, so I think that goes all the way up to, there's 150. So it looks like 144 is going to be about right there. All right. And then the next thing to do is basically a T-chart. And normally we would pick one thing on each side of the T-chart, or one side of the axis. So we might pick like we're at 3, so we might pick 2 and 4 and 1 and 5. But that's kind of redundant because we know if we do 2, we know 4 is going to be the same, right? If we do 1, we know 5 is going to be the same. So why don't we just pick the easy numbers 1 and 2 for x? So if we plug in 1 minus 3 is negative 2. Negative 2 squared is 4. 4 times negative 16 is negative 64. And negative 64 plus 144 is what? Holy cow, 80, right? Did I do that? Anybody want to check my work? Nobody wants to check my work? Somebody check my work. Okay. And if we check 2, 2 minus 3 is negative 1. Negative 1 squared is 1. 1 times negative 16 is negative 16. And 144 minus 16 is what? 128? I know that one's right. So at 1, we're going to be at 80, which would be 60, 70, 80 right there. Oops. 144, that's not 80. No, 50. Sorry, 60, 70, 80 right there. That's better. And we obviously know at, what's that going to be? It's also going to be 5, right? So 5 and 80. Not a great graph. At 2, we're going to be at 128. So at 2, there's 110, 28 right there, which we know is also going to be there. So our graph is going to look, hopefully we make a nice smooth graph. And how did I know that thing's going to bottom out at 6 seconds? How did I know it was going to hit 6 seconds? Come on, guys. The math would check out if we plugged in 6, you're right. Because 6 minus 3 is 3, 3 squared is 9, and 9 times negative 16 is negative 144, and negative 144 plus 44 is 0. But there's an easier way. Riley?
The max is at 3 seconds.
Yeah. Because we know parabolas are symmetrical, if it takes 3 seconds to get to the top, it's going to take 3 more seconds to get to the bottom. So a total of 6 seconds in the air. Because remember, we have what we call a axis of symmetry, and 3 seconds to the top, 3 seconds to the bottom. Okay, number 4. Sunshine Manufacturing Company produces 10 solar water heaters per day. If they were to increase their production, income from sales would increase, but so would their expenses. If they were to decrease their production, both their income and their expenses would also decrease. Since they want to maximize their profit, they ask a business analyst to determine a profit function. The analyst estimates that the profit Y for production X units per day is given in this formula right here. How many units should they produce to maximize the profits? So here's our equation. So what should they produce to maximize their production? Or the question wasn't that. The question was, how many should they produce per day to maximize their production? Anybody? Scott? 14. Excellent. How do you know 14?
Because it's in the H buffer.
Well, there you go. That's right. This is X, the number of produced, and this is Y, the profit. Well, you guys remember, it opens up. That right there is 1464. Your maximum, and that's where you want to be at the peak. Your maximum, remember, Y is profit. So that equation shows the maximum profit comes when you are producing 14 heaters. Okay? No work to do at all. More reading than there was work. Number 5. The yearly profit function P of X for a company selling X items is given by P of X equals negative 3 times the quantity X minus 16 squared plus 400, where P of X is in thousands of dollars. What is the maximum profits that this company can expect in 1 year? Justify your answer using complete sentences. Okay, so what do we do here? Anybody got an idea? $100. Any idea, guys, what we should do? We want to. It's $400,000, isn't it? Because the vertex is 16 times 16 400. Which remember, this is in thousands, so 400,000. So they got to produce 16 of whatever they produce to earn $400,000 in 1 year. Okay, a yearly profit function. All right, moving on. The profit P of X made by selling phones at price X can be modeled by this function right here. Oops, that function right there. What price will maximize the company's revenue? $400 per phone, right? $400 per phone because their vertex is 418,000. So if they charge $400 per phone, they'll earn a maximum profit of $18,000, I guess. Okay. What is the maximum revenue? $18,000, right? What profit could the company expect if they change the price to $500 per phone? Why do you think their profits would decrease at this rate? Well, less people would buy them, right? They're more expensive. Of course, Apple is proving that wrong as they raise their phones from $700, $800 to $1,000. So how much profit would they make? Well, we could simply plug it into the equation. So that would be 100 squared, which is 10,000 times 1/5, which would be negative 2,000 plus 1,800. Hopefully I got all my zeros in the right place, and I believe their profit would go down to $16,000 if they charged an extra $100 per phone. What profit does the function predict if the price is $800 per phone? Well, I'm thinking it's going to be, anybody got an idea?
Your thing dropped out now.
Is it still recording?
Yep. Oh no, it's screen came back.
All right, let's see. So it's going to be 400. Get a calculator. It's going to be 400 squared because 800 minus 400 is 400, and 400 squared is 16,000 times 0.2. No, sorry, yeah, 0.2 is 32,000. Is that right? Somehow something's not right there. Negative 32,000. So they could expect to earn negative $32,000?
No.
Or negative $18,000?
Yeah.
No, negative $14,000. So that probably wouldn't be a good idea to raise that price to $800, right?
No.
But once again, Apple has proved them wrong. Okay,